Hi friends, today we are going to learn no display problems in 5th generation onward laptops. So 5th generation onward laptops, like the CPU's name, the code name is Broadwell, Skylex, Kabylex, Copylex. All this processor are the single unit, like there is no PCH, no ICH, no MCH, no graphics, no clock chip. Everything within the CPU. There's no need of any supporting chips. Okay, so that is the one thing. And the total motherboard works only on 4 chips. Only the CPU and the Super IO, SIO, it's called the EC, embedded controller, then the BIOS and the RAM. So these are the only 4 chips which the motherboard works. Now if you have a problem which not giving the display, so how to check what is the problem? So first you have to connect the motherboard to the DC power supply, check the current. The current should be about 350 milliampere. Okay, and if the current is okay, then what you have to do is you have to check all the voltages. Like you have to check, you see all the coils are here. These are the all different coil. The different coil give the different voltages. Like here you should get a 3.3, then 5 volt, then 1.35 here, then 1.05 here, and then something 0.7, and here also something 0.7. All this voltage you should get here. So you have to check all the voltages. All coils should give a different voltages, right? And if the all voltages are okay, then the CPU, that's SIO, generate one signal. That signal is called the EC power okay, or the system power okay. We'll see in this animation. Okay, we'll see in this animation when the all powers are okay, like in this diagram, when the all this coil gives the proper voltages, okay, except this coil, because this coil is connected to the battery. So no need to check this voltages. Remove the battery and check all the voltages. The all coils should give a different voltages, right? Now if all coils are giving the voltage, then this SIO generate one signal that is called a power okay signal, or the system power okay signal. This 3 volt signal, you have to take down the diagrams, and you have to check the signal name is power okay or the system power okay. The power okay or the system power okay signal means that this 3 volt signal coming means the all motherboards getting the proper power. Okay, so this 3 volt will go to the CPU. Now the next is, once CPU get this 3 volt from the SIO confirmation signal, that means all power is coming proper, then the the CPU generate one signal that is called the PLT reset or the platform reset. This PLT reset is a reset signal. The CPU reset himself and he send out this signal to the SIO. This signal going to entire motherboard, like audio, then network, and then Wi-Fi. This signal goes everywhere, you reset everywhere. This signal you can check on Wi-Fi card. This one is a Wi-Fi card slot. You can check this signal on the Wi-Fi card pin number 22. Okay, you have to check on the pin number 22. At pin number 22 you will get a 3 volt. If you get the 3 volt there, that means the CPU generate the PLT reset. That means all powers are okay, and CPU generate the reset signal, which you can check on the Wi-Fi card pin number 22. Okay, and now the PLT reset is okay. Then you have to check the next signal is called, after PLT reset you have to check the next signal is called the DRAM reset. Okay, this DRAM reset. The DRAM reset signal coming from the CPU and it goes to the RAM. You have to check the signal. It's going to the RAM. At RAM pin number 30. Pin number 30. You have to check the signal at pin number 30. You will get here 1.35 volt. You will get here a 1.35 volt. If 1.35 volt is coming here, that means the CPU generate the DRAM reset and CPU most probably working and is ready to communicate with the RAM. Okay, so you have to check the signal, the DRAM. Now if this signal is okay, then you have to check the next signal. The signal name is the clock. This clock department inside the CPU. CPU have, there are two crystal, okay, the 32.7 kilohertz and the 25 megahertz. The 32.7 kilohertz is basically used for the RTC circuit, is basically for the real-time clock, and this 25 megahertz crystal is basically used for the clock sections. His CPU receive this 25 megahertz and generate a different clock. This clock you can check on the SIO pin. It's called the LPC bus. There is a pin name LPC clock. At LPC port you will get your 33 megahertz. Okay, you have to get your 33 megahertz. You have to take out a diagram and check LPC clock over there. And if this clock is not coming, okay, if this clock is not coming, then you have to check this crystal, 25 megahertz crystal. You take oscilloscope and check your 25 megahertz crystal oscillation is coming or not. If the oscillation is not coming, then change the crystal first, then problem may be solved. Or if after changing the crystal still clock is not coming, then the possibility fault could be the CPU. Okay, so you have to check the CPU like that. So you have to check the clock at LPC port. The next is after clock, then the CPU access the BIOS. CPU access the BIOS. BIOS is a 8-leg pin BIOS. BIOS pin number 1 is a chip select, pin number 2 is a read, pin number 4 is a ground, pin number 8 is a power. It's like that. So these pins are more important. Of course there are 8 pins have a different function, but for us there is 2-3 pins are more important for checking the signal. Connect oscilloscope here at pin number 1 and turn on the laptop. Keep the oscilloscope on 1 volt and you will find a pulses here. You should get a pulses here. If this pulses will not come, if not coming, then that means the possibility could be the CPU. The CPU could be the possibility. So hit the CPU with the BGA machine or try to hit with the OTG O1. In all circumstances, first you have to heat the motherboard with this OTG O1. Put it in the oven or try to heat on the BGA machine with a 220 degree. If after the heating also the problem is still there, see CPU doesn't send this chip select signal like this, then the possibility fault could be the CPU. Then you have to check on the pin number 2. The signal name is called the read. This signal coming from the BIOS toward the CPU. CPU read the BIOS. You have to connect oscilloscope here and you will find some pulses over there. And if these pulses are not coming, then the possibility could be the BIOS chip is bad. So you have to check that. Okay, and if the pulses are coming, then still you can try to flash the BIOS and recheck whether display is coming or not. Okay, so after the BIOS, the next signal you have to check the frame signal. The frame signal. This frame signal you can check on the SIO. You can check on the SIO. It's called LPC frame. Here is not a fixed frequency or the LPC frame. There are the pulses. You can check the signal with the oscilloscope. There will be some pulses on initial levels when the CPU access the bus. He generate a pulses. So if these pulses are coming, then the possibility are the CPU is working, CPU access the BIOS and he is doing the pulse is called the power on. It's generating the signal. Now the next is, if after the frame signal, if the frame signals are coming okay, then you have to check the next signal is called SMBus. This SMBus is a two-wire communication protocol between the CPU and the RAM. When CPU doing the push, it's called the power on self test, at that time CPU read the RAM, and on the RAM there is a small chip, there is a small 8-pin chip. That chip is called SPD. That chip is called SPD. The SPD means serial presence detect. The SPD is a chip which hold all the information about the RAM, means what is the capacity of the RAM, what is the speed of the RAM, who is the manufacturer of the RAM. So before giving the display, CPU access that SPD, and SPD tell the CPU all the information about the RAM. So this signal on the pin number 202 you can check with the oscilloscope, or you can use a RAM card tester, put the RAM card tester on the RAM slot, use oscilloscope there. You can't check all the signal by multimeter, you have to use oscilloscope there. You have to use oscilloscope, check on the initial level, you will find a pulses over there. If these pulses are coming, that means a CPU is reading the SPD. Okay, so you have to check the SPD like that. Now if the SPD is also okay, then the next signal CPU generate, the next signal is called the SMBus to the display. So you have to check the SMBus to the display, and if this SMBus is perfect, if the display panel is there and display panel is CPU access the panel, then CPU send a video signal, that is called LVDS signal, and that signal on the step of 9, and the display will appear. So in this way the display come on the 5th generation motherboard. So in this motherboard what you have to do is, you have to, if the display is not coming, so first try to heat the motherboard. Try with the BJ machine, or try to heat with the OTG oven at 125 degree for 20 minutes. If the heating is okay, you have done the heating, but still display is not coming, check all the voltages, check the PLT reset, check the DRAM reset at pin number 30, then check the BIOS pin number 1 and 2 whether it is accessing or not, and try to flash the BIOS first, and if check the clock at here on LPC clock. If the clock is not coming, then try to replace this crystal, 25 megahertz crystal, and the next is check everything first. Of course first try to change the RAM only, and then just proceed this sequence which I explained you. So in this way the no display problem can be solved. Thank you very much.